A lot of the people in this room are currently infected with tuberculosis. You're welcome. Actually, a third of the global population is infected with this incredibly deadly pathogen. There's no proper treatment. There's no cure for the type of infection that 1/3 of the population has because it is invincible in the lung lesions that are currently being presented here. People with active tuberculosis have a treatment that can last up to 2 years, cost nearly $500,000 per patient, and it is highly toxic. This has led to the creation of the so-called TB superbug that actually is invincible to all antibiotics, but one treatment method that is so toxic it causes peripheral nerve death. So TB is a global problem. And how are we responding to it? Well, there are 14 vaccines in clinical trials that manipulate the wrong type of immune response, and over 20 antibiotics that actually led us here in the first place. Clearly, we're taking the wrong approach. Well, until now. You see, we've been using Volt nanotechnology. It is a biocompatible nanocapsule that every multicellular organism produces to deliver non-antibiotic chemical inhibitors to TB granulomas where TB has so far been invincible. The capsules are small enough to permeate the granuloma and eliminate TB from the human body, thus being categorized as a first cure for tuberculosis. And not only this, we can treat patients with symptoms. The 10 million new infections every year that occur can be cured using this method by preventing TB from ever going to sleep. Because, ladies and gentlemen, that's what current treatment does. Patients with symptoms simply have the bacteria asleep in their lungs, and it can reactivate at any time. The treatment we're offering has no resistance markers whatsoever. And it is relatively, so far that we know, universal across all strains of tuberculosis. What you're looking at right now is the first schematic for a cure for the deadliest infectious disease known to humanity. Any questions?